we have just consumed one pre-trained model. It's time to play a little bit. I have one more project for today, which is the object detection. This object detection model also uses this Onyx runtime. Let me close this. But it can tell not just the age of a person based on his or her image, but it can tell what can be seen in the picture. And we have 1000 options. So first we need to do something. We need to download this ResNet Onyx model from this page. Okay, so what happened, I just downloaded the model from this link because it is just too big to be committed to GitHub. It is 200 megabytes or so. So I provided the link where you can download this model and also the MD5 hash of this file, because as I observed, there are many models with this name. I have OpenSSL. And it calculated 0A16, 0A16, very good. So it seems that I have downloaded the right model. First of all, let's check the project file. So what I need is the Microsoft ML library for machine learning, image analytics, Onyx runtime because we are using Onyx model, and Onyx transformer because we want to use it in our pipeline, Microsoft ML Vision because we want to load images, and the Ski Sharp TensorFlow Redis. This is needed because this is actually not needed. Okay. You can create a standalone executable. So everything will be copied to the binary folder, and later on you can use this code if you want to play a little bit. Okay, let's check how this code works. Not very complicated. Some pre-validation, so we need to provide an image here. I have one image here. I just downloaded it from the internet, as everybody does. And you need to provide an image. I just save the current working directory into a variable because I will need it to find the model later on. What we do, we just load the image, and the output will be this image virtual column, of course, because it will be the input for the next step, which resizes the image to the right size. If we go to our well-known Netron page and we open the model, and the model in this case is located here. Fortunately, I'm on the Ethernet cable, so it doesn't take too much time. So if we investigate the input data of this model, then we will see that we will need a 224 times 224 image, RGB image, and the result of this model will be vector of 1000 integers. And the name of the output tensor should be something like this. But if we go to our code, then we will see maybe everything is provided perfectly. So we need to resize our input image into the expected sizes, and then we need to extract the pixels. The output column name will be data. Why data? Very good question, because the input of this model is called data. Input is called data, and if we come here, then the output of this step will be data, the input will be image, the image is the resized image, and as I mentioned in the very beginning of this video, it needs to be scaled back to the range of 0 and 1, because the neural networks always work with floating point values between 0 and 1. This is absolutely essential. If we don't do this, then this prediction won't be accurate. The order of RGB channels are defined here. I played a little bit with it, and it turned out that doesn't really matter. So the neural network seems to work on monochrome images, so they are color blind, or at least this model. And then we just apply this ResNet model. This is a pre-trained model, as I mentioned, and we just do the prediction. We do exactly what we did earlier, so we just fit the pipeline with 0 data and create the prediction engine with the input model. The input model in our case, it is very simple. We just provide the image path, and the output model will be what we already saw here. So the output will be, this is the name of the output, and this is the 1000 element long vector. Okay, so we just do the prediction based on the argument that was provided in the command line, and what the prediction engine returns is the 1000 element long array, and each element of this array represents how likely the input image is something. But what something is defined in this text file. So if we receive that the fourth element of the image is 99%, then it is most likely a tiger shark or something written here. So we need to do some data manipulation and find what most likely this image is. We only take the 10 most likely element, and we just convert it back to a text, and then just print the result. Let me show you how it works. So in the launch settings, I provided a cat as an argument. So if we just start the code here, somewhere here, press F5, then we will receive the path of the cat here. We just create the ML context. This is the print working directory. Okay, excellent. We just don't provide data for fitting the model because it has been fit. And then we creating the prediction engine, and the argument here is the cat. Let's just do the prediction. It is very quick because prediction is not that computer intensive than training a model. Okay, so we just determine what the most probably values are. Here is the result view. You can see, but also in the command line, you can see that this is a paper towel. Yeah, not a bad finding because here is something which is similar to paper towel. But we can see that Egyptian cat can be seen in this picture. It is quite a good finding. Or a tiger cat, I don't know, maybe some kind of other, and then toilet paper. Yeah, maybe this is a toilet paper, or at least the neural network thinks. Candle, I don't know, maybe not. I don't know what a lynx is. Or a bath tower, yeah, or a space heater. Interesting. But most likely it is or a paper towel or an Egyptian cat. Maybe the cat is much more probable than the paper towel.